Hey guys, welcome back. We're in the middle of talking about Newton's laws of motion, and what we're going to start out with is a simple box resting on my horrible drawing of a flat table, and the box sitting there, and it has some forces acting on it. I didn't put any units for the forces. Typically it would be newtons, which is N. I didn't want to just make this drawing any worse than it was. We're going to say the mass of the box is 10 kilograms. We have a 5 pulling backwards, a 5 pulling backwards, a 10 this way, and a 20 pushing down on the box. Now this could represent your car. You're trying to pull it forward and you have two joker friends that are trying to hold it back, and somebody's sitting on it, or you're trying to slide a sofa. We could call whatever, but these are the forces acting. Now the first thing we want to do when we have any kind of forces acting on an object is draw what's known as the free body diagram or force body diagram. What it's going to do is take this object and free it up from anything that's touching it and replace it with a force. So since it is touching the ground, we're going to replace it with a normal force. Now that's really the force of the floor, force of the table, but we call it normal force. Normal is the math way of saying perpendicular. So when it touches a surface, it actually acts perpendicular to that surface. Now we have a 20 pushing down, so we put the 20 still there. There's still a 10 going this way, and we have a 5 back here, two 5s. Now the only thing we're missing is we have to include, because the box has mass, that means gravity will be pulling on it, and gravity always pulls straight down from the center of the box. And that is the force of gravity, which we calculate as being mass times gravity. Alright, that gives us units of force, or newtons, units of force, and also there. So there we have our free body diagram that shows all the forces, and it removed this tabletop. Now the way we have to look at this now is use Newton's laws. And we're going to start out with Newton's first law, so Newton 1L, and that's saying add up all the forces and see if they equal 0. Okay? Now I'm going to start in the vertical direction first. I'll tell you in a later video why I like doing that. But anything that points down, since we're going to call positive up, anything that points down is negative. So we have a minus 20. Over here we have a minus mg. And we have a plus f of n coming up. And that's adding up the three vertical forces, y direction. I'll put that y right there. And that has to equal 0. If we go through and solve that, we get f of n equals mg plus 20, which is 10 for the box, 9.8 for gravity, plus 20, should be 118 newtons. Now what does that number mean? That number means that the floor, or the force of the floor, the tabletop, or whatever this is sitting on, f of n, has to hold up 118 newtons. It thinks that the apparent weight of the box, or what the box appears to weigh, is 118 newtons. It doesn't know there's an extra 20 there. It just says, hey, this box weighs 118 because I have to push up with that much. Now, apparent weight, f of n, becomes important later down the road when we start talking about friction. Alright, so let's look in the x direction. Call positive to the right. If we looked at, we have a minus 5, a minus 5, a plus 10, and we're just summing the forces. Does that equal 0? And actually it does. So if it equals 0, we can say that all the forces cancel, so it doesn't move. That box will remain stationary. Really what I just did here is just said I'm summing all the forces in the x direction equal to 0. Is that true? Well, it turns out that they do cancel. These two to the left cancel the one to the right, and there's no friction or anything else, so that doesn't move. So what do we know from this problem? We know the box appears to weigh 118. We know it's not going to move left or right. Okay? And that all stayed within Newton's first law. Oop, Newton's first law, I don't know what happened there. Which is where we start. We assume it doesn't move, and mathematically it'll tell us if it does, which is going to be the next problem. We're going to do a problem where the box actually does move, and we'll see what the math tells us. So, hope that helps you out. We'll try to do one more of these, just make it a little messy and see what happens there.